Hi everyone, my name is Fred. I'm the head coach at Yousuli. Welcome to the Epic Endurance podcast, where we take a deep dive into strength, endurance and conditioning. Today we're going to talk about a failed CDA field test. CDA being the coefficient of aerodynamic drag, basically the amount of resistance you're facing when you're riding your bicycle. The greater the resistance, the more power you need to put to go at a certain speed. For this specific test, I played a bit on my last day in France before flying back to the States, and I've been playing with 3 different setups. Setup number 1 was on a road bike with a cycling kit from ASOS and whatever helmet I could salvage here and a pair of sunglasses. I'm using in all of them my triathlon shoes, not the most aero, but very comfortable, still fairly aero. I'm riding on the hoods. I can see that this position is not extremely aerodynamic, but fairly comfortable and very easy to handle. Also, I did not bother even adjusting the saddle height. The saddle height was a little too low, which might have improved my CDA a bit, but definitely reduced my comfort and my power. I felt that pushing into higher numbers was difficult, and I had discomfort in my knee. Setup number 2 was on old time trial bike, also running 28mm tires, but the rims here are much wider. These were 88mm rims on both the front and the back. Tire pressure fairly low on this one, probably in the 70s, where the other one was probably at 80 psi. Same shoes, different kit though, using a tri-suit, somehow aerodynamic tri-suit. As you can see on the posture, I'm fairly flexible. My arm strings and lower back fairly flexible, and I feel very, very comfortable leaning forward. I have misplaced front water bottle, which usually helps with drag. Left it back home. And setup number 3 is the same thing, but with Oha, my long-haired Dachshund dog, on the back. She's fairly aerodynamic, but obviously it's increasing the amount of the surface and catching wind. Also, she has a tendency to put her pose and stand up to take the wind when I'm leaning forward. Sometimes she puts her head down, but sometimes she just puts her pose on my head, increasing drag. Testing conditions were not perfect. I would not test clients on this kind of weather. We had bursts of winds at around 45-50 kilometers. Not a constant wind, which would have been okay, but bursts which make reading quite complicated. I have been using multiple ways to calculate CDA. I'm using an aero sensor, which looks at the air pressure, the speed, the power. By itself, it tries to filter out the noise. And then I'll also look at the data and trying to filter out the noise as well. And then also trying to input this into the aero calculator that we have online. The readings, eyeballing it, I can see that obviously the road bike is going to be the slowest, and then Oha in the middle, and then me alone the fastest. I would have given me something like 0.25 to 6 on me alone, probably a 0.3 with Oha, and maybe a 0.33 or 35 on the road bike. The results were a little different. When I tried to filter out the noise, on the road bike, I was getting something like a 0.325. Looking at calculation based on the data we had, I overridden the air pressure, so temperature and altitude is not very important. Me at my postpartum weight, the bike weight actually was about the same on the road bike and the TT bike. A small segment. When I'm looking at the calculator online, I'm often using a loop segment, so I can negate the climb and the wind, which definitely is not working here. When I'm using the aero sensor, I'd rather have wind only in the front, if no wind at all, because wind from the back is kind of complicated. With the wind in the front, basically the sensor can know how fast the wind is coming and which direction, how it affects also aerodynamics. Aero sensor was going for something like we said 0.325 or 0.32. Here we are going at a 0.515, so not great at all. I think the aero sensor is probably closer to the mark. Obviously, doing field test or mathematical testing is better when external conditions are more favorable. So this is really like the worst day to do that. For the setup number 2 was me alone and filtering the data from the sensor. I fell in something closer to 0.235, I would say, which is a little better than what I expected as well. The raw calculation will put me something closer to 0.369. Still varies an order of magnitude here. Again, small short segments, burst of wind, very difficult reading. Last one was with OHA, and the aero sensor was giving me something like 0.275. Here we're falling back to 0.472, which is in the middle, like I guessed. The scaling on the CDA calculator tracks and will reveal differences, but again, this is not perfect in this kind of weather. Like I said, not the perfect day for testing. I do believe that like most of these results have a slight positive bias coming from the sensor. We are going to take them as face value. I would not, generally speaking, but I just want to illustrate how much, in this case, with this kind of setup and this kind of result, what kind of performance can we achieve on a specific course. Obviously, the faster you go, then the more important your aerodynamic become. You do want to improve your power, but to a certain extent. I think a lot of people, especially long course athletes, are obsessed with things like critical power FTP, which is a good metric, and you do want to train that, but you don't race at FTP, you race at much lower intensities, especially on a long course triathlon or even a 70.3. And spending a bit of time fine-tuning your setup can make a big difference. If we're looking at a race like Indian Wells La Quinta, which is Ironman 70.3 happening this December, which I'm scheduled to do, very, very flat course. Actually, the total elevation is negative. You end up a little lower than where you started. It's a little longer than 90K, so it's 90.54 kilometers. I'm using the same kind of metrics that we have on the calculation here. I just want to show you, so here you can override the CDA. If we're to try to go for like a 3 hour, which is decent time, not the fastest, but a decent time for a lot of triathletes, a 3 hour at a CDA, like the one I had on the road bike estimated, would require about 149 watts, let's say 150 watts. If I was with my dog, I don't think they would allow that. The same will take 20 watts less, 130 watts. Now we're changing and we are going on to TT bike. Time trial is strongly affecting my posture on the bike, and then the same time, and let's say 0.235, same time would require 115 watts. A lot of watts saved. I could be training the same amount, and this will be a very, very easy workout for me, obviously. Now, if we wanted to go a little faster and get into a bit more competitive field, going at 230, so that's an average of 36.2 kilometers per hour. At this CDA will take me about 185 watts. With OHA will take me about 210 watts, and we say 325, 242 watts. So that's quite a big jump, almost 60 watts difference between the road bike and the TT bike here. For people that do ride with power, 60 watts, it's quite a bit, and trying to scale up your metabolic performance by 60 watts will require a lot of effort. So I do encourage you to try to improve your posture on the bike. I do encourage you to use this tool, the Bike Power Speed Calculator, ideally in better condition than I did today. Even in bad condition, this could help you see which setup is performing better and how to save watts. I hope that this was helpful. If you have any questions, feel free to contact me, and I will see you next time.